Hey, it's Alex Williams of the New Stack. Welcome to the New Stack Makers, a podcast where we talk about application development, deployment, and management at scale. The KubeCon plus Cloud Native Con conferences gather adopters and technologists to further the education and advancement of cloud native computing. The vendor-neutral event features domain experts and key maintainers behind popular projects like Kubernetes, Prometheus, Envoy, Core DNS, Containerd, and more. Hey, it's Alex Williams here of the New Stack, and we're here at KubeCon plus Cloud Native Con in San Diego, California. It is day one, really, and on the keynote stage today, there was some discussion about database clusters in terms of Vitess and its graduation. And Sugu here is one of the people behind Vitess with the company PlanetScale. So Suggoumarane?
Sougoumarane, yeah.
Suggoumarane, CTO PlanetScale, co-creator of Vitess. And we're also here with Quinton Hoole, who is technical vice president at Futurewei, and he leads, or one of the leads at the storage SIG. And so I have some interest in storage and kind of the intersection with databases. And I think you shared a conversation earlier about a conversation you had with someone, and it seems like there is like this point in time where I would sense it a few years ago when we were talking to someone in a podcast, was actually in Austin, and we asked about storage, and she said, "Why are you asking me about storage? Like, I don't mention storage in my book." And I was like, "Oh, really?" It's a kind of a funny kind of, because it was a book, it's about Kubernetes to some extent. And now here we are, and we hear a lot of discussions about state. We hear a lot of questions about statelessness and what's ephemeral and what's not. But there's not as much, I don't think, historical understanding of storage that there might be with people who have actually been in the business for a while. So maybe we could just talk about that context that you bring into this. Like, what is the context that you provide that you think of, and when you think about where we are now, and where we are now with thinking about databases in these new, very distributed environments, it's really extending even past the data center now. So I'd just be curious on both of your thoughts.
Do you want to take that one, Sugu? Well, so for me, it started in the early days. I was one of the original people on the EC2 project, and we kind of had to figure out what cloud meant and defined a lot of the concepts that have now become mainstream. I think, elastic block stores and in the storage space and various other databases, etc. And so that was sort of where the conversation started for me. And then over time, it's evolved, and I think Kubernetes was very much focused initially on these stateless workloads and didn't do a very good job, to be perfectly honest, of providing any kind of support for storage, other than to the extent that you could connect to an existing, typically public cloud provided block store or something similar. I think that's evolved a lot over the last several years. There are many different, cloud native databases. There's Vitess and there are several others. And people, I think, are starting to do serious stateful workloads in the cloud and in Kubernetes in particular. So yeah, I mean, that's sort of the progression that I've seen so far. What we as the cloud native storage or the CNCF storage SIG try to do, because this space is very complex, there are many different ways of solving several of these problems. There are different layers. There's block stores, file stores, databases, key value stores, and many others. And often they're layered on top of each other in different ways that have different properties. So what we're really trying to do is clarify the space a little bit for the poor users out there who just want to say, I want to run XYZ application, it needs to be available and this fast, and what are the options I have? So what we're trying to do is clarify that and show them these are the different options that you have for different use cases. These are the pros and cons of the different options, and hopefully enable them to make informed decisions rather than be bombarded with marketing from various different vendors and projects telling them that their solution is the best for everything, which is typically not the case.
So you come from a deep storage background, and Sugu, tell me about your background and how you bring context to where we are right now.
So my background has been more from a relational database. It goes back to, I've been working with databases since the 90s. I was at Informix. That's where I started working with databases. And then ended up with X.com and PayPal, where we also ran a relational database. And eventually YouTube, where we actually used MySQL and sharded it. So my view of storage is very, very biased towards using databases, because that's something that we have used a lot and benefited a lot from. And it was kind of almost a culture clash to be acquired by Google, where Google is a company that kind of proposed we don't really need a database as far as storage is concerned, the whole NoSQL movement. And even within Google, there was not much support for SQL or databases during the early days. So that's changing now, but that's kind of, in some respect, Kubernetes inherited those biases from the fact that it was born from Borg, and Borg also was a very stateless focused workload orchestrator. There's also the other side. When you get into storage, especially the database type storage, there are a large number of configuration options. And it is very hard for an orchestration system to support all those combinations. And typically, it's much easier to have an opinionated way of saying, this is how we believe it should be run. But when that happens, then there's a whole bunch of workloads that get left out. So it's a difficult problem to solve. The exciting part is SIG Storage is here to think through all those complexities, and we hope that we'll be able to come up with really good recommendations about how to configure storage.
It's all on you, Quinton.
Well, don't hold your breath too long. But at least I have been thinking about this stuff for close to 15 years now, so the stuff we haven't figured out probably isn't figured out at all.
So what about that precedent then from Google and really not having this context themselves about state, right? They didn't really have to think.
Yeah, I don't think that's totally accurate. I mean, I think there's a lot of workloads in Google. A lot of the infrastructure at Google actually came out of the search and ads businesses, because those were the big ones very early on. And they are fundamentally, kind of batch workloads. Yeah. So they do a lot of batch, they trawl the internet, they, index all this stuff. And then a lot of the serving is done out of stateless front ends that with statically loaded data in them, typically in RAM actually, because of the latency requirements. So yes, I mean, it is true that there was a lot of emphasis on low latency stateless workloads, but somebody captures all those ads. There are advertisers who actually upload their ads and they get shown. Yeah. Those get stored somewhere. And Gmail's been around quite a while, and you can imagine there's a bit of storage behind that. So it's not the case that they have no storage or did not prioritize storage. I think what they did recognize very early on was that a lot of the traditional storage services, and this is the same experience that Amazon had many years ago, the traditional kind of monolithic relational database, which was very common 15, 20 years ago, didn't typically work at the kinds of scales that both of those companies needed to operate at. And so in Google's case, they built a lot of their own bespoke stuff. So all of the stuff that came out of MapReduce, Bigtable, and all of these kinds of things. And they spent a lot of engineering effort getting that stuff working, and it works very well inside Google. So and that all runs on Borg as well. So it's not the case that Borg couldn't run things that were stateful.
Yeah, I may be misunderstanding how Google works, but it felt like, so I came from YouTube, was acquired by Google, so that's the impression I got, that Borg is mostly stateless, and like if you wanted to store data and run your application in Borg, services like Bigtable and Colossus were provided to you as an API.
That is definitely true.
So it was not, they were not necessarily run as Borg services. How you would run your application on Borg is different from how Bigtable gives you a service. So in some respect, it's kind of like what Kubernetes gives you in the CSI API, where the services run outside, but there is a formal API, but it's not necessarily run within Kubernetes. So so when they just ported Borg out into kind of the ideas of Borg into Kubernetes, these things were considered external, like they were considered external in Borg. Of course, Google has probably the biggest data in the world for all you know, right? So, but engineers never had to deal with the details of how it was stored. Engineers mostly wrote stateless applications, other than the infrastructure people who built these Bigtable and Colossus frameworks.
And that there's corollaries there to Amazon too as well. I mean, and in Kubernetes, what we see is the evolution of the API, which serves as really the nexus in some respects for Kubernetes, and that then extends into how the concepts of storage are viewed within Kubernetes. So as that API has evolved, as those APIs have evolved for Kubernetes, what is the evolution that we're starting to see now? What is it that we're starting to see in terms of storage and the APIs that really makes that difference for bringing us to something that comes out of Borg, but is now something that's representing the use cases that have not normally been attainable in the community?
I can maybe have a stab at that, and I need to preface it with the fact that I have not been actively involved in a Kubernetes storage SIG for a long time.
Right.
So my history with storage and cloud native storage comes from actually before that, and now we're more focused on the CNCF level of storage, which Kubernetes is part of that, but there's all these other Vitess and other projects, TIDB, etc., that are also part of that picture. But my take on it, and Sugu, I'd be interested in what your reflection is, that we're seeing a fairly clear sort of stratification. So there are definitely cases where traditional block stores need to be exposed to containers, and they're typically remote block stores, so things like EBS and most of the cloud providers have equivalents, and attaching those to containers in a suitable fashion, having standard interfaces so that anyone who provides a block store can interface with Kubernetes and have their block stores attached to Kubernetes as volumes. The same thing for file systems. A file system is a fairly well understood concept. There are many vendors, open source projects, and commercial vendors that provide file systems, and the ability to attach them to Kubernetes via the appropriate interfaces is stabilizing. I think that stuff is pretty mainstream now. Those interfaces were developed several years ago now, and they're gaining wide adoption. And then I think we're seeing a proliferation at a higher level than that of all these more specialized storage solutions. So object stores are one obvious example. Databases, relational or otherwise. There are various different flavors of databases. Some of them provide different levels of transactionality, different levels of availability, durability, operational complexity. There really are a lot of dimensions to the problem, and there really isn't actually, as far as I can see, a one size fits all at all. As soon as I think when you're building small, relatively simple applications, you can kind of use anything. You can store your data in etcd, you can store it in MySQL, you can store it in any one of the other things, and for the most part, it kind of works. I think when you get to the scale of what a lot of people are starting to use Kubernetes for, and we saw some very interesting presentations by the likes of Lyft and Zoom and Slack, etc. Today, these are big installations with very large fleets and very serious storage requirements, high availability requirements, and then I think you end up needing much more specialized solutions to the particular problem you're trying to solve, and it becomes very important to understand the trade-offs that you make. Is this a highly durable solution that's perhaps lower performance? Is this a high performance system that perhaps doesn't provide as much durability? The term consistency is one that gets bandied around a lot. I always like to use it as an example. There are at least 6 different kinds of consistency. And if you ask most people, do you want a consistent database? Yes, I want a consistent database. But that we could speak for 2 hours about what consistency means and whether you need it or not and what you trade off to get it. So,
Yeah.
I don't know if that answered your question.
No, it's good. It's good context in terms of where, how we think about storage. I'm curious from your point of view.
Yeah, I think the cool thing is Kubernetes, after it was formed, actually is starting, in my opinion, to leap ahead of even Borg was. Like even today, if you are at Google, you don't get block storage. You either use Bigtable or Colossus. There is no block storage that you can use, whereas Kubernetes now has that for you. And the fact that that these people now know some of the things that they had to unlearn from their previous things. They are actually making really good decisions, being cautious about not going too fast and then committing one way or another. So I think it's, in the way I see it, it feels like it's the right pace at which features are being introduced for supporting storage.
That's interesting. It's starting to move ahead.
Yeah.
And I guess that makes sense if you're considering those, those corner cases that you couldn't really resolve with Borg, right? And now we're able to resolve them better. I'm curious about the context then of Vitess, and perhaps you could explain to people what Vitess is for those who may not be familiar with it, and how it fits into the overall context in that evolution.
Yeah, so Vitess, so given this, it's good that I talked about Borg because it is Borg that kind of made Vitess what it is today in some form. We initially developed it at YouTube data centers. It was meant to be run on-prem. And in 2013, we had to migrate all our data into Borg. And when we went to Borg, we didn't know how are you going to move this MySQL-based sharded system into Borg where there is no support for block storage. The only services available are Bigtable blobs or Colossus, right? So we made a decision saying that we are going to run Vitess as if it was a stateless application. So what that meant was we deploy Vitess in just regular stateless application mode, which means that Borg would come and take you down and all data is ephemeral, it'll just wipe your data. But what we did was we set up enough redundancies with replicas and stuff that everything was disposable or survives takedown. And so that is essentially how we ran Vitess in YouTube when we moved it to Borg. And that is the reason why we basically became cloud ready before Kubernetes was even written. And when Kubernetes was announced in 1.0, we were the first ones to come out and say, hey, you can run storage in Kubernetes using Vitess because that's exactly how we ran it inside Borg at YouTube. So that's the background as to why Vitess calls itself cloud native.
And so how has Vitess evolved? And how do you see it now, emerging now in this, maybe it's a segue into discussion about this intersection of data stores and storage?
So Vitess actually, after that, actually, Vitess was actually highly customized to work with YouTube. It had no transparent sharding. It had gRPC APIs. So it was a very custom system. And we realized that if it continued that way, people will not adopt it. So that's when we decided to actually push it towards being more compatible with something so that's what the industry expects. When they come to your product, they want to see some compatibility with something that's already out there. And in Vitess's case, it was MySQL. They said, well, if you behave like MySQL, if you talk like MySQL, I think we'll use your system. So we pushed Vitess more towards looking like MySQL. And that kind of gathered momentum. Slack, for example, they were one of the early adopters that got excited that, then it means that I can easily migrate we can easily migrate our MySQL app into Vitess because it speaks the same protocol.
It speaks the same protocol.
Yeah.
It was interesting actually when Vitess first came to the CNCF, and we have a very transparent process whereby we, evaluate projects for inclusion into the CNCF, and everyone gets to chime in and say, yes, we think this is a good member of the CNCF or not. And there was quite a lot of controversy around Vitess specifically at the time, because people said, well, it's just MySQL. MySQL's not cloud native. Why do we want this? Clearly, MySQL is not cloud native. That's why everybody builds, Bigtable and all these other things, because those are cloud native. We don't want it, in the CNCF. And I think I was one of the people who argued that, first of all, what does cloud native mean? I mean, at the end of the day, it's kind of encapsulated by a highly available, horizontally scalable, automatically managed, all these kind of properties that we associate with cloud native things. And Vitess is actually all of those things. It does look like MySQL, and it does, is compatible with it, but it's actually has all the properties of a cloud native system that vanilla MySQL does not. And that's essentially the crux of the matter. I don't know if you agree or disagree with me, or if you remember
No, that's exactly true. I remember during those times, even cloud native wasn't well defined.
Yeah.
There was arguments about what that means.
Yeah. I think it's becoming clearer.
Yeah.
Well, that's a debate, I think. We could have.
I don't know if you remember.
The definition keeps getting updated. I saw actually Sean Michael Kerner in our Pancake Breakfast this morning said that service mesh is now included in the definition.
Well, so the definition, actually the definition has stood the test of time fairly well. I think we've updated it once or twice in 5 odd years now. So I think that's kind of a reasonable definition.
That's pretty good.
And I think that, there's 2 parts to the definition, and I can't recite it for you now, but there's the first part which defines, the properties that make something cloud native. And then there are a bunch of examples of the kinds of things that provide those properties. And service meshes are one of them. There are many other ones, microservices, etc. So I think, as time evolves, people create systems and new industries around solving the same problems, and those then become examples of how you provide the properties that you're looking for, which is high availability, high scalability, etc.
So today and looking forward, and we have a few minutes left, how do you see that evolving then, from the discussions and the projects, that you're working on, in the storage SIG, and how does that intersect with projects like Vitess?
I don't.
Or conceptually even. Because we're talking about databases, we're talking about data stores, we're talking about storage environments, we're talking about, how you think about persistent storage, how you think about block storage, how you think about file storage, and then you're talking about, kind of ways you can access this data. There's lots there. So I'm curious on how, in all of that swirl, where are we right now? What are you looking at moving forward?
That's a difficult question.
It
so
is.
I think our a couple of key things that we look at. The one is just terminology, making sure that people out there's a plethora of terminology, and it's made somewhat complicated by competing vendors, and everybody's cloud native, etc. So just being clear about what the words mean and how they interrelate, being clear about what the different kinds of storage are, and the kinds of deployment mechanisms that you have. You can have distributed storage, you can have relatively centralized storage, tightly connected, loosely connected, etc. So making sure that everyone understands what all the options are, and then I think making it clear what the pros and cons are of the different combinations. And there are many permutations of layering these things together, and you get good or bad properties depending on what your use case is. And then standardizing on things like performance benchmarking, or durability benchmarking, or consistency benchmarking, all these kinds of things. I think they're sufficiently difficult that for everyone to have to go and understand all those problems and figure them out themselves is just not very efficient. So if we can come forward and say, here's a good set of tools for measuring the performance, and if you're wanting this kind of data store, evaluate your options using this fairly standardized way of evaluating, and then you'll get reasonable numbers that you can use to inform your decisions.
So Sugu, any thoughts on this event? What are you looking at? What are some of the kind of topics of interest for you? You graduated from the CNCF, that must lead to some discussions in terms of the future of the project. What are you thinking? What are some of the milestones you now are seeking to reach?
Yeah, the thing we are thinking is, I suddenly feel like, are we ready yet? Are we ready for people to come and flood with tests? Is the first worry. And the biggest one of those is to make it much more usable. So that's definitely what we are going to focus on. Because there is this thing where as the user base grows, their tolerance to the lack of flexibility of a product comes down. So they expect the product to do a lot more things by itself,
right.
Things to be taken care of. So that is what I would call the fear, and that fear is motivating me to think that we should spend a large amount of time making this approachable and usable in terms of with tests. Yeah.
Well, thank you both for taking the time to talk with us today. Have a great KubeCon, and look forward to following the progress of Vitess and the storage SIG, and appreciate your perspectives in terms of your experiences and knowledge in this space. It's very helpful.
Thank you.
Thank you.
It's been a pleasure.
The KubeCon plus Cloud NativeCon conferences gather adopters and technologists to further the education and advancement of cloud-native computing. The vendor-neutral event features domain experts and key maintainers behind popular projects like Kubernetes, Prometheus, Envoy, Core DNS, Containerd, and more. Listen to more episodes of the New Stack Makers at thenewstack.io/podcasts. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.